Hello, favorite students, and welcome to another edition of Online Physics with Mr. Peacock. Today we are talking about energy and how we solve conservation of energy problems with LOL bar charts. We're in your workbook on page 166. We're working on number 31. In this problem, we have a box. It starts at rest. We push it, and there's some friction, and then at the end, it's moving. It's got some velocity, but it's still on a flat surface. I start with my LOL chart. This side of my chart is before, point A. This side of my chart is after, point B. And then here's what's happening during. This is the work. So in my system, I'm showing only the box and the Earth. At point A here, I see that I'm at rest. I'm not moving. So since I'm at rest, kinetic energy equals 0. I'm also not lifted above the ground. I'm flat on the ground, so potential energy gravity equals 0, and there's no spring, so spring potential equals 0. At the end, I know I'm moving, so I've got 2 bars here of kinetic energy. I'm still on flat ground. I'm not lifted, so I've got no gravitational potential, and there's still no spring, so I have no spring potential. I also need to show the work. This is what's happening during. So there's a push force, and that is adding energy. So that's doing positive work. So I drew an arrow going in with 4 bars. There's also some friction slowing the box down. That's pulling energy out. That's doing negative work. So I drew 2 bars. So if I think about all of my LOL chart together, it's 0, the total here, plus the 4 from the push, minus the 2 from friction, equals the 2 kinetic energy at the end. So then we're going to write our equation. Mechanical energy, or total energy at the beginning, plus the work that happens in the middle, equals the mechanical energy final at the end. That's our conservation of energy equation. Mechanical energy breaks down into 3 types: kinetic plus gravitational potential plus spring potential plus the work equals the kinetic plus the gravitational potential plus the spring potential at the end. The kinetic at the beginning is 0, the gravitational potential at the beginning is 0, the spring potential at the beginning is 0. We have to show both types of work. So the work from the push is positive, the work from the friction, pulling energy out or slowing it down, is negative. And all of that equals the kinetic energy plus both gravitational potential and spring potential are 0. We're going to put in the equation for work. If you remember, work is equal to the force times the distance times the cosine of the angle. Here, the angle is 0. The cosine of 0 is just 1. So the work is going to be the force times the distance. So that's what I've done here. I've got the force of the push multiplied by the distance that it travels minus the force of the friction multiplied by the distance that it travels equals 1/2 mv squared, which is our equation for kinetic energy. When we do this math out, we get 200 over here equals 5v squared. If you're wondering where this 10 came from, it says that the weight of the box is 100 newtons, which means its mass needs to be 10 kilograms from our equation for gravity force. That means we put for mass 10 kilograms right here, mass. That comes out to be 5v squared. When we simplify that, we get velocity as the square root of 40, or 6.32 meters per second.